Professor Robert Lee and other audiences. We are Group 10B of IEG1001 Mentorship Project. Today our topic is Evolution of Data Propagation. As we all know, in the ancient times, people have already realized that they need to coordinate. And so they need some way to communicate with each other. And then language is born, but not like all social animals. For human beings, it is a special talent and means a long process evolution. Through developing, more things are obtained, and then people want to keep track of them. The problem is how. Here are some examples of data in the form of simple images. And they finally develop into alphabet. Through writing, documentation enhances the ability of thinking, and another evolution occurs. In the Song Dynasty, Chinese scientist Bi Sheng have already invented the mobile tab to copy files, while in the West, the invention of copying led to the Age of Enlightenment in Europe. Now, many methods of communication are still used today in some signs. For example, the sign language. Beacon developed into semaphore, and singing developed into loudspeakers. And something more commonly used are body language and finger-spelled alphabet.
In the middle of the 20th century, after the first computer ENIAC was born, data propagation meets a great evolution. A large number of new technologies appeared. They changed the world from stem to stem. I want to introduce several new technologies developed in 20th century. The first one is VSAT, very small aperture terminal. It's a good two-way satellite ground station with a dish antenna that is smaller than 3 meters, such as from 75 centimeters to 120 centimeters. The development of VSAT experienced 3 periods. The first one is C-band, whose frequency is 6 GHz. It's the first commercial VSAT, and it only receives systems by equatorial communications using spread spectrum technology. Next one is Ku-band, whose frequency is from 12 to 14 GHz. It's developed by Schoenberg Olyfield Research co-developed with Hughes Aerospace in 1985 to provide portable network connectivity for airfields, trailing and exploration units. The last one is Ka-band, whose frequency is from 18 to 31 GHz. It's used by many huge organizations such as Walmart. The VSAT has many weaknesses and strengths. I want to introduce the strengths first. First one is availability. VSAT services can be developed anywhere, having a clear view of the clock belt. And the diversity is also another strength. VSAT provides a wireless link, completely independent of the local WLAN infrastructure, especially important for backup or disaster recovery services. The next one is the deployability. VSAT services can be deployed in hours or even minutes. The fourth reason is VSAT can deliver high-quality internet performance regardless of latency by using onboard acceleration or protocols such as TCP or HTTP. The last one is security. Corporate-grade VSAT networks are private layer 2 networks over the air. There are also 2 main weaknesses of VSAT. First one is latency. VSAT links are subject to minimum latency of approximately 500 milliseconds roundup. Another weakness is encryption. The acceleration schemes used by most VSAT systems rely upon the ability to see a package source and contents. Packets encrypted via VPN defy this acceleration and perform slower than other network traffic. The future of VSAT is very bright. The improved SSS satellite system will promise the higher bandwidth rates for lower costs. The VAST VST will provide applications as many as possible for residential and business users. Another new technology is GSM, the Global System for Mobile Communications. It's the most popular standard for mobile phones in the world, and is used by 3 billion people across more than 212 countries and territories. The development of GSM experienced 4 periods. The first one is 1G. It's an analog cell phone standard that was introduced in 1920s. The voice will be modulated to higher frequency, typically 150 amperes and up. The next one is 2G. It's using digital signals between the handset and the towers. It divides PDMA-based and CDMA-based standards, depending on the type of multiplexing used. It introduces data services for mobile such as SMS text messages. The third one is 3G, and it enables network operators to offer users a wider range of more advanced services while achieving greater network capacity through improved spectral efficiency. Services include wide area wireless voice, telephone, video calls, broadband, wireless data, and HSPA data transmission capability, able to deliver speeds up to 14.4 Mbps per second on the downlink and 5.8 Mbps per second on the uplink. The final one is 4G. It provides a comprehensive IP solution where voice, data, and streamed multimedia can be given to users on an anytime, anywhere basis, and at higher data rates than previous generations. The last one I want to introduce is the fiber optical communications. It's a method of transmitting information from one place to another by sending light through an optical fiber. It was first developed in 1970s. Fiber optical communication systems have revolutionized the telecommunications industry and play a major role in the advance of the information age. Compared with electrical transmission, the strength of it